In this video, we will be learning some synthetic pathways to make amines, and we're going to make a flowchart that's going to help you solve every problem on your exam. So this is part one. Part two will involve every amine problem involving benzene as well. Okay, so first way to synthesize amines is through reduction. So the exam problem may give you some sort of functional group and ask you to make this amine. So both of these will follow reduction, and we'll talk about some reductive methods later. But this can come from just adding HNO3 and H2SO4 on a benzene. And usually aldehydes and ketones come from an alcohol, which come from halides, which could come from a radical reaction. So these are your reduction methods. There's one more, and that is when you're given this acyl azide, or when you're given an alkyl halide, because that's where they come from. And here are the reagents. I mentioned this one already. And this one in particular comes from NaN3 in heat. Okay, and this makes an acyl azide. Now all three of these use reduction, which is defined as reducing CO bonds and increasing CH bonds. So what that reduction may look like, usually a good one is hydrogenation in Ramies nickel. But another good one for reducing nitrose is iron in acid, followed by a neutralizing base. This one's good for nitrose, to reducing nitrose. Another one would be using NaCNBH3, sodium cyanoborohydride, with the amine, which could involve some sort of alkyl group. So this one is good for reducing aldehydes and ketones, but this option is good for both of these. I'm just giving some of the more common methods that you might find in the textbook or on the exam. And there's one other reduction method, the classical one. This, followed by proton source. So this one is particularly good for cyanides, acyl azides, as well as amines. And you end up having an amine in which step? Yes, in this step. So this step is you're adding an amine here, and then that forms an amine. So you want to reduce that amine into an amine, and you would use a reduction method here. Okay. Now, there is one other synthetic method, and that is when you're starting with some sort of acyl group. So you could start with an amide. Well, not you, but the exam could start with an amide. Or it could start with an acyl chloride. Or it could start with a carboxylic acid. But just know that these follow the same pathway, so it's really nothing daunting. And to make this work, we use SOCl2. And to turn this into an amide, we use the nucleophilic substitution. It doesn't have to be NH3, it could be an alkyl group as well, and we use some sort of solvent. And to convert amide into amine, this will be, once again, okay, this will not be a reduction. So you might think, oh, I'll just take this out. Well, actually, there's a special reaction, and it's called the Hofmann rearrangement. I have another video on that. So you put it in these conditions, and also some water. Quick tip, anytime you use hydroxide or hydronium, it's always followed by water, and it won't hurt to add heat as well. So this is very interesting. I made the video because we're taking away this carbonyl carbon. Okay, so the R group used to be attached to this carbonyl carbon, but in the rearrangement, we get an isocyanate where the R group is now attached to the N. So then these two become the leaving group. So this is a special way to go from amide into amine. Okay, so this is everything you need to know how to make amines. I'll have part 2 on reactions involving aromatic amines, but major takeaway from this video is just know this flowchart so that on the exam when they give you a starting reactant, you know what you need to do to get to that amine. And as for reduction methods, quick recap, you could use reductive amination, which involves this and this, to convert aldehydes and ketones into amines. If you want to convert nitro into amines, you could use this hydrogenation, or you could use the iron and acid. And finally, lithium aluminum hydride and H2O is your classic way of reducing double bonded nitrogens, such as the following, or triple bonded nitrogens.